Hi, we're Team Jam Session.
My name's Julia, and on this project I mainly worked on the servo motors and integration.
My name's Aditi, and I worked on the detection algorithm.
My name's Maya, and I worked on the mechanical design.
Our goal with this project is to create awareness about the importance of sign language. So, we created an interactive art piece that reads American Sign Language gestures and presses a corresponding key on a piano. This is how we did it. Step 1 is reading in the images. We use the PyCam 3 and OpenCV to read live images from the camera. Each one of these frames is then sent to the MediaPipe library. The MediaPipe library is used to determine landmarks of the hand. These landmarks are coordinate points which indicate particular orientations of the hand. As you change the position of your hand, the arrangement of the landmarks changes. Each set of landmarks becomes one data point in our pickle file. To determine which ASL symbol is being displayed, we use the random forest classifier from the scikit-learn library. This uses machine learning to decide which symbol is being displayed by comparing the live landmark data against prior training data. After the random forest classifier determines which symbol is being shown, it returns a number between 0 through 7 representing a particular letter. In this case, the new image would share most data points with F and is therefore classified as number 3. We use this to determine which servo we need to move.
Initially, we would send this value over to the Arduino Mega through UART and use that to move the servos. However, we eventually realized that this was inefficient and error-prone due to noise, and decided to connect the PWM servo board directly to the Raspberry Pi, which saved us from needing excessive hardware.
Now, we use multithreading to ensure our program works seamlessly without delays or glitches. Multithreading is a process by which two separate parts of a program can run simultaneously. We did this by creating a queue. Each time a character was classified, it would be put into the queue. This queue was accessed through a function called workerThread, and because queues use the FIFO, first in, first out method, this character would immediately be taken out of the queue first. In workerThread, which ran simultaneously with PyCam, the function would check if the sent character was a repeat of the last character, and if not, move the servo motor corresponding to the piano key.
Our project also includes lights, specifically the NeoPixel RGBW lights from Adafruit. In order to activate the lights, we use the UART connection between the Pi and the Cytron Maker Pi RP2040. This is necessary because the RP chip in the Pi 5 is not compatible with the NeoPixel lights. Each time a hand symbol is detected, we send it to the Cytron, which then activates the corresponding color of lights.
After the correct key is pressed down, we return to the top of the loop to get the next frame and character.
Each module contained 3 servo motors, and these cases made it easy to attach the motors to the frame. The original prototype for the frame was a freestanding wooden structure that we placed next to the piano. A major issue was that any movement of the structure caused misalignment of the keys, which meant that we had to constantly recalibrate our values. Now our frame crimps onto the piano with a slide base. It's held together with screws and wood glue which strengthens the joints. The design is also sleeker and moves less, making it easier to transport and reducing misalignment.
Here's our project in action.